Alright, so in part 2 of this video, we're looking at determining the surface area and volume of pyramids whose bases are equilateral triangles. So in this case, in our first example, first of all, let's look at our formulas for a moment. We need the area of the base, the perimeter of the base, the slant height, and the height. And you may or may not recall from the first video that the slant height and the height form a right triangle along with the apothem. So in this case, we need to make sure that if we're not given both, that we use that Pythagorean theorem to find whichever one's missing. In this case, we're given an equilateral triangle whose base edge is 24 inches long. So let's look at that triangle for a minute. Start with our equilateral triangle, where each side is 24 units long. The other thing that we are given is that the height of the pyramid is 8 square root 6 inches, which means we're given h. We need to find L, and we do that using the apothem. The apothem extends from the center of the base down to the midpoint of one side, which means this side that was 24 units long is now 12 units long. And as we discussed in part 1, the apothem is related to this 12 by the 30, 60, 90 relationships. So a times the square root of 3 must equal 12. We divide both sides by the square root of 3 and rationalize on the right. So on the left side, we're left with a, and on the right side, 12 square root 3 in the numerator and a whole number 3 in the denominator. In this case, the 12 and the 3 are evenly divisible, so a would become 12 divided by 3 is 4 square root 3. We need that value of a to determine the value of L. So now we go to our Pythagorean theorem, a squared plus h squared equals L squared. In this case, 4 square root 3 squared plus the height squared, 8 square root 6 squared. It is my advice that anytime you have a square root that needs to be squared, use your parentheses to remind yourself to type them into your calculator in that form. Equals L squared. So now when it's time to type it into the calculator, I'm going to start with the parentheses. 4 square root 3. Now my calculator opens another set of parentheses automatically when I type a square root, so I'll have to close my square root twice. If your calculator did not put that parenthesis in there automatically, then you'll only close it once. Squared plus another parenthesis, 8 square root 6. Here again, I'm going to close mine twice. Squared. So L squared is equal to 432, which tells us that L will be the square root of 432. If this is a perfect square, if the square root of that number is a whole number, you'll want to simplify it. In this case, it isn't. If I were to press the square root of 432 into my calculator, it comes up as a decimal, so I'm going to leave it in this form. I'm not going to round it at this point. All right, now we have H, we have L. We need the area of the base and the perimeter of the base, which takes us right back to this triangle. So I'm going to draw my triangle separate yet again, so I can find the area and perimeter of it without the clutter of the A itself. All right, so I know it's equilateral, which makes finding the perimeter nice and easy, 24 times 3. So the perimeter of that base, 24 times 3 is 72 inches in this case. Now let's find the area. To find the area of a triangle, you need the length of the base edge, which we know is 24, and we need the length of the height. Keep in mind that's another 30, 60, 90. So here the height divides this segment into, or this side into 2 segments, each 12 units long, which makes the height 12 square root 3 for that triangle. So the area of the base, the area of that triangle, 1/2 of the base edge 24 times the height 12 root 3. Here again, 12 square root 3, that square root of 3, if I were to type this all into a calculator, is going to give me an irrational decimal, one that's not going to end, it's not going to repeat. So instead, we take half of 24, which is 12. 12 times 12 is 144, and we leave the square root 3 as part of that product. 144 times the square root of 3. I don't want to round anything here. Now that we have B, we have P, we have L, and we have H, we're ready to find the surface area and volume. So surface area to start off with is capital B plus 1/2 capital PL. In this case, capital B, I lost it, 144 root 3 plus half of the perimeter 72 times L, which is the square root of 432. I almost am going to run off the page here. There we go. Onto the calculator. 144 square root 3 plus half of 72 times the square root of 432 tells us the surface area is 997.66 inches squared. Onto volume. 1/3 times capital B times H. So the volume here, 1/3 of capital B, 144 root 3, times the height of the solid, which was given as 8 square root 6. And you'll notice here again, because those square roots, I'm including them in a set of parentheses for my product. 1/3 times 144 square root 3, close the parenthesis if it opened one, times 8 square root 6. There again, close that parenthesis. So our volume in this case is 1,629 and 17/100 inches cubed. Okay, at this point I would advise you to pause the video, attempt the second problem, and then come back and check your work. Okay, so assuming you've taken some time to work through this second example, I've gone ahead and worked out the entire solution for you. I started off by taking our equilateral triangle base, drawing in the apothem, knowing that that cuts this side length of 36 into 2 equal parts, making this part 18. So A times the square root of 3 equals 18. We divide by the square root of 3 on both sides and rationalize, then simplify. A should become 6 square root 3. Using that Pythagorean theorem then, A squared plus H squared equals the L squared value we were originally given. Now, I've included here the 6 square root 3. When you square it, you should get 108. And 18 square root 3 should give you 972. So then solving that, we get our H value here as the square root of 864. There again, that's not a perfect square, so I'm going to leave that just as a square root form for now. Okay, so moving on, to find the area of the base and the perimeter of the base, I went ahead and drew my triangle a second time and drew the height of the triangle in, understanding there again that the height is going to divide that segment into 2 congruent parts, which means this segment's going to be 18. Using that special right triangle, this short 18 times the square root of 3 becomes the height of that triangle. Keep in mind that height is not the same as this height, which is the height of the prism. All right, so in that case, the area of this triangle, 1/2 of the base. Now remember to use the entire base here, which is the 36, times the height of the triangle, should simplify to 324 square root 3. And the perimeter 108. So these I've just outlined in pink just to draw your attention to them as points of reference for you to check in your solution. Then we substitute these values into our surface area and volume formulas to get the answers that are seen here on the screen. If you have any questions, you know how to contact me, and hopefully you're doing well with this.